In this module of playing with numbers, we are going to learn about test of divisibility. Now, test of divisibility. Where to apply? Now, divisibility rules of whole numbers are very useful because they help us to quickly determine if a number can be divided by 2, 3, 4, 5, 9, 10, 11 without doing long, tedious division. That means that if you are able to divide a number evenly, for example, take 8 can be divided evenly by 4, leaving remainder 0 and quotient 2. So let us get started. There are certain rules. So first rule is divisibility rule for 2. So all even numbers are divisible by 2, or we can say that the digit at one's place should be 24680, then that number is divisible by 2. For example, here you can see number 5437. It is having 7 as its unit place. So 7 is an odd number. So as it is an odd number, the number 5437, that is 5437, is not divisible by 2, whereas the other number 7998 is having 8 as unit place. So 8 is an even number. So the number 7998 is exactly divisible by 2. Divisibility rule for 3. Now for this, suppose a number is given to you, that is 5437. You are supposed to find the sum of the digits of that particular number. That is 5 plus 4 plus 3 plus 7, and it is coming as 19. So 19 is not a multiple of 3. 19 doesn't comes in the tables of 3. So the number 5437, that is 5437, is not divisible by 3. Whereas if you take the number 7998, so if we add the digits, we get 33. So 33 is a multiple of 3. So we can say that 7998 is divisible by 3. In short, we can say that if the sum of the digits of the number is divisible by 3, then the number is divisible by 3. Divisibility rule for 4. Now in this, you are supposed to see the last two digits. If the last two digits is not exactly divisible by 4, then number is not divisible by 4. And if the last two digit is divisible by 4, that is, it is a multiple of 4, then the particular number is divisible by 4. Here you can see the example given of 5437. 37 at the unit place and tens place, you can see it is not divisible by 4. So the number 5437 is not divisible by 4, whereas the number 7988, having 88 as a tens and unit place, so 88 is divisible by 4. So the number 7988 is divisible by 4. In divisibility rule for 5, you can see the unit place is having either 5 or 0. In this number there is no 0 or 5, so it is not divisible by 5. In the number 7995, the number is divisible by 5 as it is having 5 at its units place. Now for divisibility rule for 6. In this, you have to test the divisibility by 2 as well by 3. So the divisibility test by 2, if the unit place is having even number, then the number is divisible by 2 and the sum of the digits should be divisible by 3. Why? Because 6 is a multiple of 2 and 3. 2 3s are 6. So it has to satisfy the divisibility test of 2 as well as 3. Let us take an example, that is 5437. From the first instance, you can see that the unit digit is not even, so it is not divisible by 2. As it is not divisible by 2, it is not divisible by 6 also. Similarly, you can see the other number, that is 7998. So seeing the unit digit, you can say that it is divisible by 2. So let us go for the next step. The next step is to check the divisibility by 3. So I have to add the digits of the number given. So on adding the digits, I got the number 33. Yes, 33 is also divisible by 3. So as the number is divisible by 2 as well as 3, so it is at the last divisible by 6 also. Now let us check divisibility rule for 7. So divisibility rule for 7, let us take an example first. 5437. Now what you are supposed to do, you are supposed to segregate the unit digit and you have to double it or multiply by 2. So as I have done, multiply 2 by 7 and you are supposed to subtract it from the remaining digits. The remaining 3 digits 543. As you can see, yes, the last digit I have double it and I am subtracting it from the remaining 3 digits. So on subtraction, the difference comes 529. Now 529 is not a multiple of 7. So the number given, that is 5437, is not divisible by 7. Let us take another example. Similarly, twice of the unit digit I have done here 2 multiplied by 4 and subtracted from the remaining 3 digit, that is 785. So on finding the difference, I got 777. So 777 is a multiple of 7. It is exactly divisible by 7. So we can conclude that 7854 is divisible by 7. In divisibility rule for 8, the last 3 digits, yes, the last 3 digits should be divisible by 8. So if last 3 digits is not divisible by 8, so the number is not divisible by 8. In 9, you are supposed to check the sum of the digits. Likewise, it is same as the divisibility test for 3. Yes, and see that 9 is the given answer is the multiple of 9. That is 5437. The sum of the digit is 19. So 19 is not divisible by 9, or it is not a multiple of 9. So the number is not divisible by 9. Similarly, we check for the another number 7866. On adding the digits, I got the sum 27, and 27 is a multiple of 9. So it is divisible by 9. So the given number, that is 7866, is divisible by 9. Divisibility rule for 10. A number is divisible by 10 if the unit place is having 0. Yes, simply you are supposed to see the unit place. If at the unit place there is 0, then the number is divisible by 10. Yes, you remember that divisibility test of 5? Yes, so we can say that 7860 is divisible by 10 also, and as well as by 5 also, because it satisfies the divisibility rule for 5 also. Now moving on to divisibility rule for 11. Now in this, first of all, let us take an example, 5437. Now here I am not underlining the digit at the odd place, that is 7 and 4, and I am underlining the digit at the evens place, that is 3 and 5. Or else you can underline the digit by skipping one digit, that is skip 1, then underline 3, skip 4, then underline 5. Then find the sum of underlined digit first and find the sum of not underlined digit, that is 5 plus 3, 8, 4 plus 7, 11. Now you are supposed to find the difference of these two numbers. Yes, the difference of these two numbers is 3, that is 11 minus 8 is 3, and 3 is not multiple of 11. So the given number is not divisible by 11. So if instead of 3 it comes the multiple of 11 or 0, then the number is divisible by 11. Let us take an example. 61809. So here again I am leaving 9 and underlining 0, leaving 8 underlining 1, and leaving 6, right? Now you are supposed to find the sum of underlined digits and the sum of the digits which are not underlined. So 6 plus 8 plus 9 is equals to 23, and 1 plus 0 is 1. Now finding the difference, I got 22. So 22 is the multiple of 11. So from this we can conclude that 61,809 is divisible by 11. Now let us solve some examples related to divisibility test. Now on the screen you can see a number 31,000 star 42. Now this star is a number which we are supposed to find. But how? So that should be a smallest number such that when we add all these digits, its sum should be divisible by 9. That means the whole number should be divisible by 9. So we are supposed to replace that star by a smallest digit to make it divisible by 9. So for that, let us take the sum of all the digits. So on adding it, I get 10 plus star. Now 10 is not a multiple of 9. Okay. Now I have to make it as a multiple of 9. So what should I do? I cannot subtract any number because I am supposed to find the sum. So what we can do, we can add. So if we add 2, so 10 plus 2, 12, again 12 is not a multiple of 9. If we add 3, 4, 5, 6, 7, 8, so 17 is not a multiple of 9. But if we add 8, so 10 plus 8 becomes 18. So 9 twos are 18. So 18 is a multiple of 9. So on replacing this asterisk sign by 8, the number becomes 31,842, and on adding all the digits we'll get the sum 18, and 18 is multiple of 9, so the whole number will be divisible by 9. Now let us take another example. In this example, again you can see at tens place we are supposed to find the missing number, but in this case we are supposed to make that number divisible by 11. So following the divisibility rule, I will underline the digits at even places and leave the digits at odd place. So I'll add the digits at odd places, that is underlined digits, 1 plus 2 and star, and I'll find the sum of not underlined digits, that is 7, 3 and 4. So I'm supposed to find the difference here. So 14 minus 3 plus star. Yes, on subtracting 14 by 3 I get 11. So 11 is the multiple of 11. So this number will be divisible by 11. So star sign can be replaced by 0 because on subtracting 14 minus 3 only we get 11. So there is no need of another number, right? So if I replace star by 0, I'll get the number, yes, 1,72,304. So on following the divisibility rule, I get the difference of the sum of the odd even digits as 11. So this number is divisible by 11. So the value of star is 0. Now let us see the properties of divisibility test, which will help us to solve the sum quickly. Now 36 is divisible by 12, right? So factors of 12 are 1, 2, 3, 4, 5, 6 and 12. 36 will be divisible by each and every factor of 12. If 36 is divisible by 12, then the factors of 12 can divide 36 exactly. So if a number is divisible by another number, it must be divisible by each of the factor of that number. Second property. In this property, if a number is divisible by each of the two or more than two co-prime numbers, it must be divisible by their product. For example, 80 is divisible by 4 and 5. So product of 4 and 5 is 20. So 80 is divisible by 20 also. Next property, if two given numbers are divisible by a number, then their sum is also divisible by that number as well as their difference is also divisible by that number. See, let us see an example. 16 and 20 are both divisible by 4. Correct? Now on adding 16 plus 20, 36. So sum of this two number is also divisible by 4. Similarly, the difference of 16 and 20, that is 4, that will also be divisible by 4. Now what are common multiples? So multiples of 4 are, on multiplying the numbers by natural numbers we'll get the multiples. So multiples of 4 are as follows, and multiples of 6 are 6, 12, 18 and so on. So common multiples are the multiples which are common in both 4, they are existing in the multiple of 4 as well as multiple of 6. Common factors. Common factors are the factors which are occurring in both the numbers given. That is, factors of 4 are 1, 2, 4 and factors of 6 are 1, 2, 3, 6. So common factors, that is the common numbers in both are 1 and 2. So 1 and 2 are common factors for 4 and 6. Prime factorization. Now a number can be written as the product of its factor. For example, 18. 3 multiplied by 6, or we can write 18 as 3 multiplied by 2 multiplied by 3, right? But when we write 18 in form of a product of only prime numbers, when we write 18 as a product of only prime factors or numbers, then that is called prime factorization. Factorization in which a number is factorized into prime factors only is called prime factorization. Now there are two methods for prime factorization. One is factor tree method and one is division method. Let us see. In factor tree method, you can split the number, that is 6 tens are 60. Then 6 2 3s are 6 and 5 2s are 10. So all these factors are the factor of 60 and they are prime factors, that is 2 multiplied by 3 multiplied by 5 multiplied by 2. Or else you can split 60 into 3 20s are, then 2 10s are and then 5 2s are. So all the prime numbers 2, 5, 5, 3 are the prime factors of 60. This is factor tree method. Now in division method, let us take an example 60. 60 divided by 2, 30, 30 divided by 2, 15, 15 divided by 5, 1. So we go on dividing 60 by different prime numbers in increasing order till we get the remainder 1. So these are the factors of 60, prime factors, that is 2 multiplied by 2 multiplied by 3 multiplied by 5. For division, divisors should be prime number only. Thank you.